CBT Nuggets JNCIS Security Series, NAT, or Network Address Translation. Well, in this nugget, we're going to look at NAT from the perspective of what you need to know for the JNCIS security exam. So we're going to be focusing on a concept known as source NAT, even though there are several other ways to deploy network address translation. Now we'll look at those ways, but we're going to focus on what we call source NAT. Let's dive in. So what exactly is network address translation? Well, you're probably using NAT right now. If you're watching this CBT Nugget from home, or even if you're watching it, let's say, from your corporate office, you're probably being affected by network address translation. In other words, what's likely happening is that your workstation that you're using to watch this nugget on has some type of IANA assigned private address from this block down here. 10.0.0.0 through 10.255.255.255, or 172.16.0.0 through 172.31.255.255, or 192.168.0.0 through 192.168.255.255. If you're coming from your home behind a DSL or cable modem, it's very likely that you're using this address range. So generally speaking, NAT is the process of translating from a private RFC 1918 IPv4 address to some globally routable address or addresses. It can function in different directions. So that's what we're talking about here. Okay, so here's a good question. Why do we use NAT? Well, let me just say this, that eventually, as we are fully transitioned over to IP version 6, we will see NAT going away. Okay, traditional network address translation, because the original reason, the main reason for developing and using NAT in a ubiquitous fashion throughout the world was to overcome the rapid depletion of IP version 4 addresses. You know, when the architects of TCP/IP looked at what we would do with TCP/IP, I don't think they were really imagining everybody in China and Brazil getting on Google and YouTube and all that. So it was really just a 32-bit address space. Well, the new IPv6 is 128-bit, which gives, each person on the planet tons of their own IP addresses. So that's a 2 to the 128th power addresses. So, and I think it was October of 2011 when we kind of officially crossed the threshold and and ran out of IP version 4 addresses. Okay, so that was really the main reason that we used this, because organizations just simply couldn't go out and get any more of the Class A or Class B, and for sure the Class C were hard to get. So another reason why we use NAT is to hide our network addressing topology. So in a sense, we can use NAT as a security feature in the sense that, well, we want to hide our internal IP addressing structure from, different types of reconnaissance attacks, so that we aren't subject to different spoofing attacks. If people can figure out what our IP address subnets are, they can typically guess that the first available address, .1 in a subnetwork, usually goes to the default gateway or some type of router interface, and then usually the first 10 or 20 or 50 go to static devices like servers, security appliances, sensors, maybe printers, biz hubs. So it's not that hard for malicious attackers to kind of figure out what to attack if they can understand our IP addressing range and how we have our variable length subnet masking hierarchy laid out for our enterprise. So it is kind of a false sense of security because it's not that difficult, a little dumpster diving and you can figure out some corporation's IP address, but it still does hide it from just the average person who's running scanners against our network, okay? What they're finding are the translated addresses. They're not seeing the real address behind the routers and the firewalls. We also use it to redirect traffic. For example, when you use at your small office, home office, okay, you might have a cable modem or a DSL modem, and often you have some device that's provisioned from your service provider. So the service provider is giving you some public IP address on your public interface, and then everything else behind this is being port address translation or overloaded to whatever address is being assigned to that outside interface. So we can redirect traffic from a bunch of hosts to a single assigned address, or just say whatever that address on the interface is. We can also use this to accommodate when we merge networks or migrate networks. These are good systems to use for the temporary migration period. If two companies merge, for example, you might want to use NAT until you can have a complete, unifying, centralized IP address hierarchy. So when there's mergers and acquisitions, you see this. Also, if two companies merge and they're using the same address space, like they're both using the 10 dot address space slash 16 or 10.10, a lot of these network people, whether they're Juniper or Cisco, they learn from the same people. Okay, they use the same books, they use the same deployment guides, they use the same white papers and best practices. So they often use a lot of the same, RFC 1918 address ranges. Well, what happens when their companies merge? Okay, or they have a strategic partnership. Well, we can use NAT, and there's a couple of ways it's described as NAT overload or bidirectional NAT. It's also referred to as destination NAT, methods to use destination NAT, to kind of bridge two networks together that are using or have an overlapping IP address space. Okay, so NAT can accommodate that environment as well. And of course, it's also a method that we use to transition on a temporary basis to IPv6 until we can finally get a total comprehensive IPv6 solution. So lots of pretty solid reasons to use network address translation. Lots of reasons why as you get into your Juniper environment, you'll see NAT being used. So you need to be aware of that. Okay, there's basically three different types of NAT. There's source NAT, which translates the source IP addresses along with the TCP and UDP ports of matching flows. Then there's the destination NAT, which translates the destination IP address field along with port numbers of the matching flows. The static NAT option is going to translate prefixes in a symmetrical fashion. So a quick example of that would be a static NAT would be servers that are in your DMZ that are servicing, let's say, the untrusted network, the untrust zone, and you want them to statically translate to the same address and optionally port number every time. Now, it's important to realize that for the JNCIS security exam, we're really only focused on one type of NAT, and that is source NAT. Destination NAT and static NAT are concepts that you'll explore when you go deeper into the Juno security track. So let's focus on source NAT. Okay, since we're going to be focusing on source NAT in this particular nugget, let's look at the distinctives. First of all, you need to realize that with Juniper, your network address translation policy or configuration is actually decoupled or separate from your security policies. Not only do you configure it in a different area of the hierarchy, for example, edit security NAT, you can also reconfigure your layer 3 NAT components without affecting or having to change your security policy. Now, even though when we look at our actual configuration, source NAT will look like the security policy, same kind of structure and nomenclature. But remember, you're only manipulating traffic. You're only translating traffic that's allowed by the security policy. So source NAT is actually going to happen after the routing lookup, after the security policy. And by the way, like I said, source NAT is the focus of the JNCIS security exam. Anything beyond that really gets into the next level. So source NAT is going to translate our source IP address, so for example, our RFC 1918 address of, let's say, 192.168.1.50, and the TCP or UDP ports in the headers of the IP flow to some publicly globally routable IP address like 99.75.60.50. Okay, don't look that up on the internet. I just made it up. All right. It's also the most common method, and it's used to translate private IP addresses to public globally routable IP addresses. Okay, either a pool of your trusted network, let's say your pool of users, to the outside, or on a case-by-case basis, servers that are either on the inside trusted zone or out in a DMZ preferably. Now, out in the DMZ, what you want to do is you want to translate those because you want to hide the real IP addresses from the public. The SRX will translate one or more private IP addresses to a group of public IP addresses of equal or smaller size. Now, how can it be a smaller size? Well, it can be. That's called overloading. Okay, so we can overload a bunch of internal addresses to a smaller set of public IP addresses. So the TCP and UDP ports can be used to overload a single address or a smaller group of IP addresses. Now, if you from a Cisco environment, you probably know this is port address translation. Or in the newest versions of Cisco, it's called NAT hide, H-I-D-E. Okay, I want to start out looking at a verification command because the first thing you want to do is you want to see if you actually have any network translation going on your SRX. So I'm going to do edit, security policies. I'll go ahead and do a run because we're in configuration mode, and then show security flow session. And you can see I've got a session here. Notice that it's in on the trust zone to the untrust zone. Okay, so it's inbound on the trust zone, outbound on the untrust. So in with an address of 192.168.1.2 to the IP address of 23.2.60.85, and it's 443 TCPs. So this is an HTTPS or SSL TLS session. And notice that when we come back out, it's the same IP addresses, same service port, not the same ethereal port, of course, but the same addresses on gig E00. So the return traffic is showing our packets being sourced from 23.2.60.85, which is the same IP address that originated the transaction. So when the source and destination IP addresses remain unchanged, as we see here, this shows us that the traffic was routed as opposed to translated or NATed. And this is what happens when we're doing source NAT, for example. Notice that if we're doing source NAT, which we are, which would be the situation in my example if we were going to use NAT, NAT is going to happen after the route zone lookup and after the policy lookup. So that's how we're able to separate when we use source NAT, to separate this from other layer 3 processes like the lookups for the routes and the zones and the policy lookup. Now, if we're using other mechanisms like static NAT or destination NAT, which you'll learn more about when you get to the next level of Juno security, static NAT and destination NAT are processed first before the route zone lookup and policy lookup, and that's because there's translation on the destination address most likely. And so we verified that we're not actually doing source NAT, we're actually doing routed processes as opposed to translation. Now, if you were going to deploy, let's say, Cisco's ASA 5505, which is kind of similar to a 210, for example, those are really designed with NAT in mind to NAT or port address translate a bunch of internal hosts out to the internet. But the SRX is not really designed that way. It doesn't really understand the concept of internet, for example. You're just focusing on zones. It doesn't really automatically think of the untrust zone as being the internet. And as a matter of fact, it doesn't have to be. Okay. Now you can see here we're going trust to untrust. We think about untrust being the internet, but it could be a call center. It could be our corporate LAN, and trust could be the data center or a server farm. So when you configure different NAT services, you want to always be mindful of the traffic context. Okay, the from zone and the to zone. Now, once you define that, then you can figure out what you want to do with it. Is it translation of the source IP address, which is the most common? Is it translation of the destination IP address, which is a lot less common? Or maybe it's both. Now, when would I do both? Okay, if I wanted to translate the source and destination, the most common scenario for that would be if I've got two companies that are merging, or they have one company's acquired another company and they have an overlapping IP address space. And so the intermediate SRX device would be translating both on both networks so that you can have the same IP version 4 address space at least for a long enough period of time till you convince one of the companies to change their IP addressing hierarchy. Easier said than done. Okay, in our network address translation scenario, what we're going to do is we're going to configure source NAT. and we're going to use the egress interface address as our translated address. So we're going to permit host in a new zone called the extranet zone. So I'll create an extranet zone off of one of my interfaces, and we'll have the hosts in those zones get internet access through the untrust zone, and we'll translate the source IP address of the incoming packets. So the incoming packets on the extranet zone interface. Okay, so those packets will be translated to the IP address of the egress interface, which is in the untrust zone, which is, as we know, on interface gig E000. So the first thing I want to do is I want to make sure I'm in edit mode. I am. So I want to set the interface. And I'm going to go ahead and use fast007 and then .0, and it'll be family. I'm going to go ahead and do a whole configuration here to set this extranet up. So that way we can reinforce some of the concepts from previously, and then we'll translate from this extranet zone with our source NAT. So it's family inet, and we'll assign an address of 192.168.2.1/24. So the extranet, gotta get the address in there. So the extranet's going to be on the 192.168.2.0/24 network. Okay, so we need to go ahead and now set our security zones, and then the security zone we'll call extranet. Okay, and we need to set security zones, security zone. And then we'll say for extranet, you're going to be on interface FE007. We just configured that, and then unit 0. Let's go ahead and do the host inbound traffic on that interface that we saw before. So we'll do set security zones, and we want to do security zone extranet, and we'll do host inbound traffic of secure shell. Okay, so I left out this command, system services here. So let's go ahead and make sure we get that command in there. Host inbound traffic system services, and we'll say secure shell, and we'll say FTP and ping. Let's set our static route. So I'm going to set my routing options, and our default route is what it's going to be. So it's 0/0, and next hop, and for me it is 173.219.248.112. Okay, let's get into edit security mode now. Let's go to the top of the screen so we can see it better. Okay, so we have our interface set up, we've got our zone, we have our host inbound traffic, we have our static route. Now let's do, how about a couple of address book entries for servers in that zone? How does that sound? So we'll say edit zones, security zone extranet, and let's do a set address book entry for the address, and we'll say it's going to be EX for extranet, SRV for server 01, and we'll say it's going to be at 192.168.2.2, and then another one, we'll say another server in there at 2.3. So we have those address book entries. Okay, let's go back to the top, and I want to do a security policy. So we're going to edit our security policies, and the from zone is going to be extranet, and the to zone is going to be untrust. Now remember, I need to have a bidirectional policy here for both. So I'll need to also have a policy from the untrust to the extranet, but for now I'm just going to basically do a policy going extranet to untrust. Now that we're in that mode, we're going to set a policy, okay? And I'm going to call mine EX2UNT, okay? EX2UNT, extranet to untrust. And I'm going to say I want to match the source address, and we'll say any. I could be more specific, but we know it's the 192.168.2.0. We'll go ahead and say any, and then destination address, any, and then application. I think I'll do we'll make it just web services on the extranet, okay, for our partner or our strategic partner or whatever, our large vendor, our large customer. So we say Junos HTTP, and we'll say Junos HTTPS, in case you want to have SSL TLS services on that extranet. So that's what we're matching. So we'll say set policy, then permit it. If it matches any IP address to any IP address, As long as it's HTTP and HTTPS will permit it. Let's also do some logging. We talked about that. So we'll log the session init, we'll log the session close, and we'll log a count of the sessions. Let's see here, then log, is that an option or maybe is it then count? Oh, okay, then count. All right, we'll go ahead and commit that and quit. Oh, okay. I got to remove the Ethernet switching family from FAST007. So again, we can see that our configuration checkout failed. I could have done configuration check and it would have told me that. So I need to go ahead and strip away this Ethernet switching from FAST007 and then do this configuration again. So let me go ahead and do that in the background and I'll catch you back up here when I'm done. Okay, so I make this mistake all the time. Part of the reasons why I just move from platform to platform, from device to device on a daily basis. So, okay, the first thing I have to do is this. I have to delete this interface from the trusted VLAN. So I had to issue delete interfaces, interface range, interfaces trust member, and you got to remember this on the SRX. Okay, so FE007. So I remove it from the trusted VLAN. Okay, then I did a commit check and it checked out and committed. Then I went ahead and added the configuration of interfaces FAST007 family INET address and then the IP address. Also, let me do a show interfaces terse command and run show interface terse. And let's see, there's FAST007. You can see the other ones are Ethernet switch ports. Here's FAST007.0 or unit 0, and it is now family INET with the IP address assigned to it. Okay, good. Okay, now remember our scenario, right? We want to configure source NAT to allow hosts in our extranet zone to get internet access and then translate their source IP address to the egress interface of our untrust zone, which in our case is gigabit Ethernet 000. So in configuration mode, I'm going to edit security NAT. And this is basically the main configuration area of NAT. Okay, lots of options that you'll learn about later on when we get deeper into Juniper security. But you can see we've got source NAT, destination NAT, and static NAT. Those are our three main options. You can also do some NAT trace options for monitoring and operational reporting, and then the proxy ARP feature. So we're going to do edit security NAT. And this is going to be source NAT. And let's see what our options are there. You can create address pools, for example, if we're going to be doing network address translation to a pool of addresses. But we're going to go ahead and do a rule set for our situation here. And our rule set is going to be called Internet NAT. How's that sound? We're going to set the from zone to be extranet, and we're going to set the to zone to be untrust. Now we have a rule set, okay? We've also defined our traffic context, right? It's from the extranet to the untrust zone. So now we want to configure our rule to match all the incoming traffic from our extranet subnet going to any location and force NAT source to use the egress interface. So we will edit a rule extranet access. We're going to set our match condition to be the source address of 192.168.2.0/24. That's our extranet subnetwork. Then we'll set a match statement to say destination address will be all. Then we will set a then statement, so we're doing match then, source NAT to what? To the interface. Now, we could do source NAT to the pool that we would have created, which would have network address translated to, let's say, 209.165.200.2 through 200, and it would have doled out those translations on a connection by connection basis. But we're going to go ahead and translate to whatever IP address is assigned to the interface in the untrust zone, which for us is gigabit Ethernet 000. And then we're going to go do a commit. Let's do a show configuration security NAT. We see the default trust to untrust rule set, but here's our rule set right here. Internet NAT, from zone extranet to zone untrust, and then we have a rule called extranet access where this is the source, any destination, and then we're going to source NAT to the interface. But what if you want to source NAT to a pool, a translation pool? Let's go ahead and do that. Okay, doing source NAT to an egress interface is pretty common, pretty basic, pretty easy. As a matter of fact, your trust interface already does that automatically to the untrust interface. So I'm going to give you a little bit more of an elaborate example here, and I kind of had to do some setup in the background because I've already described how to set up the SRX, so I'd kind of have to fill in the blanks so we can get to the NAT stuff. So on FAST07 here, this of course goes to my extranet zone, and I also placed on 6 here, FAST006, I placed another zone, and I'm calling this the partner net. So what I want to do is I want to go ahead and keep this on the 192.168.2.0/24 network, but I want to translate to a pool of addresses to this partner net. So I want to expose the host in this extranet here as a network address translated address to the partner net. So this interface 06 here, I've assigned to that interface 209.165.200.1. Okay? Now, what I've done here in my partner net is I have a 2320, a J2320 router. Okay? So I'm going to connect through this extranet from a host here, which obviously we know is my host. It's at 2.22. It's the one I'm working on right now. So it's on this 192.168 network. So I want to be able to connect from this extranet through the SRX, and of course I had to create a policy, and my policies are basically EXT to part. That's the policy that basically goes from extranet to partnernet, and then I have another policy that is part to EXT, and that is of course is the policy for traffic coming back from the partnernet to the extranet. So I went ahead and did that. I already showed you how to do it. You know how. So we'll look at the configuration here. So I've got this J2320, which is a router at the partnernet, and the address of this interface on this router is 209.165.200.254. So what I want to do is I want to create a pool of addresses, okay? Really a pool of addresses that are going to translate on this interface. And that pool would be something like, 209.165.200.50 through, let's say, 100, okay? And you want to make sure that when you set aside a pool for translation here, and of course these will be assigned or doled out one at a time as these hosts connect through here to the partner net, it'll be 50.51.52.53 and so on. And I want to make sure that this pool has enough hosts there to accommodate for the number of users I have, but also for future growth of hosts on this extranet as well. So make sure you get a good chunk of addresses in this pool that you can translate to. Okay, so first we'll go look at the existing configuration on my SRX. And by the way, you can do the same thing. If you want to set up this scenario, you can use your other SRX and just put it on this 06 here and do the same type of thing. One of the reasons why I didn't set it up here on Gigi00 is this is already configured as my outside going to the internet for me. So I didn't want to mess with that configuration. So I'm going to go ahead and do my transition between these two zones here as my scenario. It wouldn't be a bad idea for you to do that as well to follow along. So first we'll look at the configuration, the existing configuration on my SRX 210, and then we'll set up network address translation to a pool. Okay, let's see what we did here offline. We'll do a show run config. And let me see what's up here. Okay, we'll go on down and take a look at interfaces. Okay, so here is 006, which I had to go through the process that we just looked at of making it a routable interface. And there's the IP addresses I've assigned to it, 200.1. And then, of course, here's 7 with that address. So 7 is in the extranet zone, 6 is in the partner net zone. Okay, Also have a static route created. Here's my default NAT configuration. And then we'll go down. Here's our zones. So we've got our default trust to untrust. Here's my security zone partner net, okay, and security zone extranet. I went ahead and did host inbound traffic system services all for both of these. And we can see that fast006.0 is in the partner net, and of course fast007.0 is in the extranet. Here's our policies. We already know about trust to untrust. But here's now extranet to partnernet. Here's the policy, and to keep it simple, I just matched any, even though normally the application here would be more specific, more granular, to reduce the attack surface. Same thing with partnernet, from partnernet to extranet, and then the policy is called part to X. Same thing, any, permit, okay? And so that's the basic configuration. You know how to do all this, okay? So you can go back through and look at my nuggets, and you can walk through and create the same exact scenario between your SRX and your SRX 210 and your SRX 100. In my case, I'm going to go ahead and use my Juniper 2320 router. So let me show you what I'm doing there. Let me grab my command prompt, and remember that this host I'm on right now is in the extranet zone. So let's just see if I can ping that router first in the partnernet zone, which as I showed you, was at 209.165.200.254. And okay, so I can ping it from this workstation. That's a good sign. Let's go ahead and telnet over to it. And I want to telnet because I want to create a session. So when I do show security flow session, it'll show up and I can show you the results of that. So I'm going to telnet to that same address, 209.165.200.254, and I'll log in MJS on that router, and the password is that. Okay, so there's that router. You can see it's, and I'll just do a show version real quick, and you can see. Now I created that session, so let's bring this puppy back in, and let's go ahead and do we need to edit security policies. And in that context, I'll do a run show security flow session. And there it is. Okay, so it's from the host 2.22 on this port that I grabbed to 209. There's the IP address on port 23. So it's telnet TCP, and then so it's in and out. So as we see here, there's no translation. Okay, like I showed you in the very beginning of this nugget, we're just using the routing capabilities to get the traffic, this telnet session, from this host right here over to telnet to that router in the extranet, in the partnernet zone. Okay, with that in place, and you know how to do all this, let's go ahead and create network address translation now using translation pools. So I'll say top edit security NAT source. To get into that context, edit security NAT source, and I want to set my pool. Okay, so my pool is going to be called, I like to use uppercase letters when it's something, a user defined thing like this, public NAT, and then the address is going to be 209.165.200.50, and then 20 TO 209.165.200. How about 100? That's all I really need. So there's my pool that we're going to translate to. And of course, notice I'm using what looks like public, globally addressable, addresses that you would get from a service provider, and that's usually the case. On the exam, they may be using RFC 1918 addresses for everything. They may be even translated to RFC 1918. So you kind of want to be careful there. Make sure that you kind of keep track with it. Use your white pad or your paper to kind of make sure that you know what you're translating from, what you're translating to. Okay. So now I want to edit security NAT source, and we'll do a rule set. And let's call this rule set partners. Okay. Not partnets, but partners. Okay, this is a rule set for partners. Okay, in that context now, I'm going to set the from zone as we're translating from the extranet, correct? And we're going to set the to zone, we're translating to partnernet. Now let's make a rule. So we'll edit a rule, and we're going to call this partner access. Okay, and in this partner access rule, which is nested underneath this rule set partners, we want to set with the match statement, we want to match the source address, and that's the basically the VLAN of the partner net, 192.168.2.0/24, right? And then we'll set the matching of the destination address, and we'll just say all. And then we'll do a then statement. So set then, okay, so in that case, we will source NAT to the pool up there at the top, right? To the pool public NAT. And let's go to the top. I'm fat fingering today, really bad. Okay, so let's go ahead and commit it and quit it. Let's see here. I could have piped that as well, but okay, there's public NAT. There's my pool. Okay, there's my rule set. Next rule set. Partners from zone extranet to zone partner net. The rule is partner access. We're matching the source address of that network. Any destination, then source NAT it to the pool public NAT, which we saw there above. All right, very cool. Okay, well, in this CBT nugget of the JNCIS Security Series, we looked at NAT, Network Address Translation. We talked about and defined what network address translation is, also the three major types of NAT. Of course, in this nugget for this series, we focused on source NAT. So we looked at the distinctives of source NAT and then looked at the configuration on my SRX appliance. I hope this CBT nugget's been informative for you. I want to thank you for viewing.